Hello and welcome to another video. In this problem, we're going to be working on a number of ways to divide a long corridor. And in the problem, along a long library corridor, there's a line of seats and decorative plants. We're given a zero-index string corridor of length n, consisting of letters S and P, where S is a seat and P is a plant. And one room divider has already been installed to the left of 0, and another one has been installed at the very end. And your job is to put in one divider between every group of 2 seats. So you want to divide it into non-overlapping sections where each section has exactly 2 seats with any number of plants. There's multiple ways to perform this, and 2 ways are different if there's position with the room divider installed in the first way but not in the second way. And so we want to return the number of ways to divide the corridor. If it's very large, return it mod 10 to the 9 plus 7, and if there's no way, return 0. So let's take a look at the examples. So in the first example, we have 2 groups of 2 seats, and we can only place one divider because there's one divider per every group of 2 seats, right? So there's a group of 2 seats, another one after it, we place one divider, and we can place it in 3 locations, so here, here, and here, so the answer is 3. In the second one, there's only one group of 2 seats, so the answer is 1 because we have to place 0 dividers. And in the third one, there is only 1 seat, so there's a no solution because we can't place any dividers or do anything to make it all groups of 2 seats, because there will be a section without 2 seats. So first, we can recognize that if we have 0 seats, or 1 seat, or odd seats, we should return 0, right? Because there's no way to divide an odd number of seats into groups of 2. Also, there's no way to divide 0 seats into groups of 2, and there's no way to divide 1 seat into groups of 2. So we can just go through our string, check for seats. If it's any one of these, return 0. Now the second part is going to be combinatorics. And basically, it's going to be, what we need to really figure out is how many places can we put a divider between every group of 2 seats. And our answer will be all of these multiplied by each other, right? Because, for example, let's say we have seat, seat, then we have plant, plant, and we have seat, seat, plant, plant, let's say. So something like this. And then we need one more group of seats, so like this. So let's index these. So first we're going to check to make sure our seats is actually even and big enough. Then once we know that, what we really need to know is what is the gap between the end of one group of seats and the start of another group. So we really need to know this gap here. And that's pretty straightforward to do. We can just go through our seats, maintain a count, and then anytime there's an even seat, we'll just remember the index. And anytime there's an odd seat, we can just say okay, where was our old index? And that's the gap, right? So we would store this index here. Then when we get to the odd count, we would say, okay, how far is this gap now? So for this gap is 3. That means there are 3 places to put a divider. So you can put it here, here, or here. So we can write that down as well. So for every gap between 2 seats that is length I, there are I places to put a divider. So here, like I said, there's 3. Similarly here, let's count what's the gap. The gap is also 3, so there's 3 places to put a divider, right? Here, here, here. And it doesn't really matter what's in between the group of 2 seats. If it was SPS or something, it wouldn't really matter. All we really need to know is where one group ends and one group starts. So here we can put a divider in 3 ways, and here we could put a divider in 3 ways. So then just by basic combinatorics, if there's 3 ways to put this one and there's 3 ways to put this one, our total number of dividers that we can put would be 9. And that's literally all there is to this problem. You just go through your array. We can write this down. So go through array. Every time there is an even seat, record index. Then when there is odd seat, calculate distance and get divider count for that region. And just multiply old result by that. So literally all we have to do is just go through, figure out what are the gaps, And then for every single gap, the distance is the number of different ways we can put a divider. And then all we have to do is multiply all of those by each other. So we can have our old result, and we'll just multiply it by our divider. And that's literally it. So I don't know how this is a hard problem, but I think if you do like DP or something, it's a little bit tougher. But if you just do this basic combinatorics where you just figure out like, okay, what are all the distinct places I can put a divider? And I know I have to put one in each gap, and how long is each gap? And then if you just multiply every gap by every other gap, then you'll get an answer. And yeah, that's pretty much it. So now we can code it up. So we want to get the number of seats first just to make it easier, just so we can like avoid a bunch of edge cases. So you can either use a built-in count, or you can just loop through and just count it up yourself. So we'll use a built-in count. And if seats is less than 2, or seats is odd, then we can just return 0 because there's no way to split. Now we are going to have a variable for the number of seats. So we'll say 0 initially, and we'll have a variable for our last seat, and this will give us our gap. So we'll say 0 initially as well. We'll have our result equal to 1 because we're going to be multiplying this by all of our dividers. And we'll have the mod value. So now we just have to loop through the corridor. So we'll say like for I in range length corridor, or you could enumerate it. Either one's fine. If it's a seat, then we have to check, is it odd or even, right? So if it's a seat, we have to check if it's odd or even. So first we're going to increment the seat. So we'll say we're going to increment the seat, and then from there we'll know if it's odd or even. So if it's even, that means that this is the start of a new section of seats, right? Because it can't be the 0 seat because we just found one. So that means it's a start of a new section of seats. So then we have to look at this last seat, and wherever that was, we can get our distance. So we can write, we can say if seats mod 2 equals 0, meaning it's even, then, actually, sorry, if it's even, we don't want to look at the last seat, we want to record it, right? Because if we have like seat, some gap, seat, for every even seat, we want to record its index, and then when we get the odd seat, that's when we want to look at the gap. Yeah, so if it's even, let's record its index. So we'll say last seat equals I, right? This is the index of the last seat in the group. Otherwise, we want to make sure that it's greater than 2, because we don't want to do this for the very first seat in our array, right? So for every odd seat, we do want to look at the gap, but for the very first seat in our array, like let's say we have like seat, PPs like this. For the very first seat, there is no gap because there were no seats before. So we'll just check else if. So this is obviously going to be odd already, but we'll just check if seats is greater than 1. So if we have an odd seat and it's greater than 1, that means now we want to look at the gap, and then we want to multiply the result by that gap. So we'll say result times equals, and then remember the gap is the current index minus the index of the last seat in the gap, right? So if we had something like seat, PP, seat, this would be index 1. The last seat would be at index 1. This seat would be at index 4. So we do 4 minus 1, and then our gap would be 3 here. So there's 3 places to put a divider. So now that we multiplied our result, essentially we just keep doing this. Every time there's a gap, figure out the length of the gap, and then that's where we could put our divider. And then for every, because these are all disjoint like locations where we could put a divider, we just multiply every one of these locations by each other. So like if we have 5 places where we could put a divider, and we could put, the divider in 3 places in each of those, it would be like 3 to the 5th and so on. And then finally, we want to return, at the very end, return result mod, and that should be it. It's a very simple combinatorics problem. It's just basic. Realize that like putting a divider in one gap it's mutually exclusive from putting a divider in another gap. So the total number of ways is just the total the ways of putting the divider in every single gap multiplied by each other. And we can submit. And there we go, pretty efficient solution. So yeah, I think if you do this DP, it's probably a bit harder, but if you just do this basic combinatorics, it's very easy. And for the time here, so essentially we have an O of n solution, right? And that's the other thing I forgot to mention. So in our constraints, it is 10 to the 5th. So we wanted to start with looking for an O of n solution. And we did find one using this just basic count. So we have an O of n solution because this is going to be O of n, and this is going to be O of n. And then for the space, we don't have any space because we just used constant variables. So for the space, it's going to be O of 1. So yeah, it's going to be all for this problem. Hopefully you liked it. Pretty easy one, especially if you did it this way. So hopefully this was helpful. Definitely, I wouldn't mark it as a hard problem. I'd definitely say it's a solid medium. But regardless, hopefully you enjoyed it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.